All right, so we have studied a bunch of different types of asymptotes. We've looked at vertical asymptotes and holes, which are just an extension of vertical asymptotes. We've looked at horizontal asymptotes. Now we're going to be looking at slant asymptotes, which would be an extension of our horizontal asymptotes. In the last lesson, we learned 3 rules for finding horizontal asymptotes. We learned about Bobo, Betsy, and Botno. Remember that Bobo stands for bigger on bottom. So if your exponent on the bottom is larger than your exponent on top, then your horizontal asymptote would be y equals 0. Okay. Betsy stands for bottom equals top. So if you have like an x squared on the top and you have an x squared on bottom, all you're going to do is divide those coefficients. So whatever the coefficient of the term is on top divided by the coefficient of the term on the bottom. And last was Botno, which stands for bigger on top. So bigger on top, if you have like an x squared on top but you only have a regular x on the bottom, that means that there's no horizontal asymptote. Now, if there's no horizontal asymptote, then you are going to be finding the slant asymptote or perhaps the oblique asymptote by dividing. Essentially what's happened here is if the top is bigger, that means you're working with an improper fraction, so you're going to divide it. So example 5 here, we're revisiting this from last time. We've got 2x squared plus 7x minus 1 divided by x plus 4. We have an x squared on the top, but we only have a regular x on the bottom. So we said that this one does not have a horizontal asymptote. What it does have is a slant asymptote, and the way we're going to find that slant asymptote is by dividing. Here I am actually just going to use regular synthetic division to divide this. I'm dividing by x plus 4. Remember the 0 goes in the box, so I have to set that equal to 0, so that means a negative 4 goes in the box. And then across the top I'm taking these coefficients, 2, 7, negative 1, and I skip a row. Recall that synthetic division, you're going to drop the leading coefficient and then you're going to multiply, add all the way across. So negative 4 times 2 is negative 8, and then add 7 plus negative 8 is negative 1, and repeat. Negative 4 times negative 1 is positive 4, and then add negative 1 plus 4 is 3. Recall that the last number here is your remainder. So if I'm writing this, that remainder would belong over x plus 4. And if I work backwards from here, that means that the negative 1 is the constant, and the 2 would receive an x. Now, the remainder is still written as a rational function because it's a fraction, but this part, your quotient, is not. That is your slant asymptote. Your slant asymptote would be y equals 2x minus 1. Try one more example here. We've got y equals 3x squared minus 5x plus 7 divided by x minus 2. Remember the rules for horizontal asymptote. We look at the exponents. Up top, I've got an x squared, but on the bottom, I only have an x. So if the top is bigger than the bottom, bigger on top, that's Botno. Bigger on top means there is no horizontal asymptote. Instead, you are going to have a slant asymptote, and to find the slant asymptote, all we're going to do is divide. In this case, I can use synthetic division, so I'm going to take that x minus 2. Remember, the 0 goes in the box, so if I set that equal to 0, that's going to be positive 2 in the box. And then I'm going to take my coefficients here, 3, negative 5, and 7. Remember, from synthetic division, we're going to skip a row and drop down that leading coefficient. From there, it's multiply, add, all the way across. So we're going to multiply 2 times 3 is 6, and add -5 plus 6 is 1, and repeat. 2 times 1 is 2, and 7 plus 2 is 9. The very last number is your remainder, so it's going to be 9 over x minus 2. And as I work backwards from the remainder, we've got our constant, and then the 3 would receive an x. So this is 3x plus 1 plus 9 over x minus 2. Now, the remainder, this part is still written as a fraction. That's still a rational function. But this part, 3x plus 1, that is your slant asymptote. So our slant asymptote is y equals 3x plus 1.